Okay, today we're going to review factoring, and this was the lesson from Friday, and we had to stop this lesson, so this is a two-part video if any of you were out on the day we started this, and this is part one. So first of all, in factoring there's many methods, and you have to know what to do based on how many terms you have. So as you can see in these problems, these are all binomials. They have two terms and they all have subtraction. That's why it's called difference of squares, because it's subtraction. But it's not always a squared power. It has to be an even power and a constant, or both the powers in the problem have to be even, but it has to be two terms and it has to be subtraction. Now this is what we used back when we were talking about food line. So let me review food line real quick. If I have x minus 2 times x plus 2, we found that we didn't have to FOIL that or multiply that all the way out. That all we had to do was the first times the first is x squared, and the last times the last is negative 4. So we're going to try to use the food line method to go backwards and factor it. So in this first question, what times what makes x squared? Well, they multiplied x times x to make x squared. And then you'd say, well, what times what makes 25? Well, if it's 5 times 5, it'll make 25. And the food line's always a negative times a positive, because that's the only way to get a negative in multiplication. All right, let's look at another one. So what times what makes 9? Well, not 9. I said 9 and I wrote 9. 3 times 3 makes 9. And x times x makes x squared. 4 times 4 makes 16. So now how to get that negative has to be a positive times a negative. So that's what makes it food line. And that's why quadratic binomials work with food line. But sometimes you have quartic binomials. And in quartics, you do it the same way. What times what makes x to the fourth would be x squared and x squared, because the first times the first have to be identical. And then I don't know what times what makes 256, so if you don't know, you can always take the square root of it, which happens to be 16. And then a negative times a positive. But when I look at this quartic, now that it's factored, it's got squares still in it, and still looks like I could do it again. So I do it again. X times x makes x squared. 4 times 4 makes 16. Negative times positive makes negative 16. Now it won't work for this other one, because there's no way that you can multiply a negative times a positive and get a positive. And there has to be one of each. That's really important, because the reason food line works the way it does is because if you fold it out, the inner and the outer terms drop out. They're not going to drop out if they're not opposite signs. Alright, so 81 is 9 times 9, and x squared times x squared makes x to the fourth. And 4 times 4 makes 16, and a negative and a positive. So we look at the negative one and think, well, that looks like I could go again. 3 times x is 3x, times 3x is 9x squared. 2 times 2 makes 4, one of each. So you just keep doing it till the even powers can no longer be done, or it's no longer, you can find two identical numbers that multiply to be it. But once in a while there'll be an extra step, like this one, for example. This is not an even power problem, but if I worked with it really quickly, it would be an even power problem. So I take a few of these terms out. For example, I can take out a 2 and an x and get x squared minus 16, and then it becomes an even powered problem that works for food line, because food line is all about difference of squares. These two things multiply together make x squared, because x squared, 4 times 4 is the same thing as 4 squared, which is 16, and negative times a positive makes a negative. So now we have some examples here for you to try. I want you to stop the video and do these real quick, and then we'll come back and we'll check them. So this one, well, I didn't mean to write that square. This will be 7x minus 8, 7x plus 8, because 7 times 7 is 49, and 8 times 8 is 64. Now I can't go again because that's not an even power anymore. 625 is 25, and 25, x to the fourth is x squared and x squared. 49 is 7 and 7 with a minus and a plus. I could go again with the 25, but I can't with the 7 because they're not two identical numbers that multiply to be 7. So not all fourth powers go twice. And this one I need to take a 2x out and get 16x to the 4th minus 1. Because remember, you're dividing by 2x when you take out a GCF, and 2 divided by 2 is 1. It don't drop out, it's 1. Then you say 4x times 4x squared times 4x squared makes 16x to the 4th. 1 times 1 makes 1, and a negative times a positive makes it work. But looking at this subtraction problem, I still have something that can be food-lined again. 2x times 2x makes 4x squared. 1 times 1 makes 1, negative and positive, and then 4x squared plus 1 comes back down. So that's how you do food line. Now let's look at cubic binomials. Odd power binomials, except for this one, we'd have to do some other type of method. I can't do cubics and then do fifth powers with the same method. But cubics have a pattern. You cube root it to make the first parentheses. So the cube root of each of these makes your first parentheses, which will be x and 2. And I'm not sure if that's minus or not, so I'm not going to put some signs in here right now. I'm just going to put some numbers. So that's what this part means. The cube and the cube root cancel out, giving you these two numbers that go in the first parentheses. Then you take that first number and say square the first, which will make it x squared. Square the last, which makes it 4. And then, after you do that, remember we did a square the first, square the last, double the middle on perfects. Well, this isn't double the middle. This is just first times last and put it in the middle. And then to get the signs, you use the mnemonic SOAP. Same as the original problem, opposite of the original problem. The last one's always positive. So same as the original problem would be negative, opposite of the original problem would be positive, and always positive on the end. So now you can stop the video and try these at the bottom and see if they work for you. So now we're going to look at these two problems at the bottom. So the cube root of this is 7x, and the cube root of this is 3. And the square of 7x makes 49x squared, and the square of 3 makes 9. And if you go 3 times 7x, you get 21x. Now if you use SOAP, same as the original problem would be negative, opposite would be positive, and this will be negative. Now to look at this last example, I'm going to change this to plus because we've been doing too much with negative, just so you can see a positive one. First of all, that looks like that's not a cubic. Well, maybe I can take something out. Looks like it's divisible by 2 and take out 1x. So that would make it 8x to the 3rd plus 125. And that's cube rootable. The cube root of 8 is 2x. Cube root of the 25 is, the 125 is 5. If you square the first, squaring this makes 4x squared. If you square the last one in this first parentheses, you get 25. If you go and multiply these two, you get 10x. And now let's do SOAP. Same as the original problem, opposite of the original problem, always positive. So this is something you learned back in Math 2 or 3. And we're just reviewing all these different kinds of factoring. So this is binomial cubics. It's a lot different than food line. Now we're going to look at cubics that have 3 terms. And these could have powers of 4 or higher in them, but typically this is made for cubics. It says split the problem into 2 sets of binomials. So that means that we're going to split it right here after the second term. It says take out the GCF. So 2m squared, m plus 3 would be left if I divide 2m squared into each one. I can take a 3 out on this side and get m plus 3. If you've done this correctly, those two parentheses have to match or it's not factorable. So that leaves you with m plus 3, and if I take out that GCF on both of those, I get 2m squared plus 3 is the other parentheses. Now over here, if I split the problem, I could take out 5p squared, and that'll leave me with 2p minus 5. I can take out 2, and leaves me with 2p minus 5. So 2p minus 5 is the greatest common factor now, because I can take it out of both halves of the question, and be 5p plus 2 is my other parentheses. So now stop the video, try these two questions, and then come back and check your work here in just a few minutes. So if I split the problem, I'll have 2z squared. That'll leave me with z plus 6. Negative 5, negative 30, I can take out a negative 5 and get z plus 6. And they got to match, so if you forget to take a negative out, it'll be obvious. They won't match. Signs will be wrong. Take out the z plus 6's, and that leaves you with 2z squared minus 5. Now in this last one, you can see it doesn't start with a cube, and there's x's all the way through. That's a pretty good clue you need a GCF. And I can take out a 2x, and I'll have 3x to the third plus 2x squared minus 3x minus 2. So if I take out the GCF list of the original problem, don't focus on that. Focus on the inside of this parentheses and come back and put that later. So I can take out an x squared and get 3x plus 2. And I can take out a negative 1 and get 3x plus 2. So now I've got 3x plus 2 and x minus 1, the x squared minus 1 from getting these two taken out. But that 2x is still out here. And when I look at this last one, this is interesting. Once in a while, you'll have something that looks like food line, and you'll need to do that. So x squared minus 1 looks like it would be x minus 1x plus 1 with food line, or what we call difference of squares. And so because of that, we should continue to look for that in this grouping process with cubic by 4-term problems. Sometimes they will food line at the end, and you need to look and check for that. It only works if it's minus, and it only works if it's square rootable, which is why 15 didn't work, because 2 and 5 aren't square rootable, and it's why 13 and 14 didn't work, because they're both plus. It has to be minus to be a difference of squares. Alright, so now I've gotten to the point where the first video has finished, and I will put this out on Canvas and allow you to, I put an assignment out on Canvas, and the assignment is to do the worksheet 0.1. The entire thing goes over both of these videos, and they're mixed up, so you have to have completed both videos in order to be able to understand how to do the worksheet.